All right, welcome to page 58. Here it says numbers from 1 to 50 are written on a piece of paper and dropped into a box. A paper is chosen at random. So here we have our set of 50 numbers. Let's set up our equation. We know that we have desired on top and total on bottom. We are dealing with 50 different options in total. So our 50 goes on to the bottom. Now we need to find divisors of 48. Divisor is a number that can divide 48 exactly with no remainder. Another word for this are factors. What are the factors of 48? This can be a very time-consuming process. The more you do these types of questions, the faster you will get them, and you might not need a calculator. But for the first few times, while you're getting used to these, you most likely will need a calculator. We're going to go through each number and see if it can divide into 48 with no remainder. So 48 divided by 1, no remainder, 1 is good. 48 divided by 2, no remainder, 2 is good. 48 divided by 3, no remainder, 3 is good. 48 divided by 4, no remainder, 4 is good. Excuse me. 48 divided by 5, we have a decimal, so we will not be including 5 with our factors. 48 divided by 6 is 8, no remainder. We will add the 6 to our list. What I would like you to do right now is pause the video and for the next 10 minutes, or maybe 5 to 10 minutes, fill out the rest of this workspace and highlight all of the factors of 48. All right, welcome back. Now that you have filled these out, I am going to quickly fill out my space to match yours. Let's see if we have the same answers. Okay, now let's find our desired number. Let's count all of our highlighted numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 50. Okay, let's move on to question number 2. Find the probability of choosing prime numbers. Okay, so first, what is a prime number? A prime number has only two factors, okay? One and itself. So for example, 2 is a prime number. 2 can only be divided by 1 and itself, which is 2. Another example would be 5. 5 can only be divided by 1 or 5. Okay, so now that we understand what a prime number is, we are going to highlight all of the prime numbers. Now you could potentially try this out. For example, 4 divided by 1 equals 4. 4 divided by 2 equals 2. 4. So already we have too many numbers. 4 divided by 1, 4 divided by 2, and 4 divided by 4. That's too many. We can only have two factors for it to be considered a prime. In your classroom, you might have a poster of all of the prime numbers available. That is something you can relate or refer to. You could use your calculator to find out each one, which is very time consuming, or you can follow along with me, and over time, we will memorize what these prime numbers are. And there's one last thing to be reminded. 1 is not a prime number. Okay, we will not be including 1. All right, now that we have all of our prime numbers highlighted, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 over 50. Okay, let's move on to question number 3. Find the probability of choosing composite numbers. A composite number is the opposite of a prime. It has more than two factors. Okay, this is something that we are used to at this point. So basically, we're going to be highlighting all of these numbers that are missing up here. We're going to go into this box. Okay, and I just want to remind you also that we are not going to be including 1 with with our um, with our set. 1 is not a composite number or a prime number. All right, let's start highlighting. All right, let's count up our composite numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. We have 34 over 50. Excuse me. All right, let's move on to question number 4. Find the probability of choosing a number with 4 in the tens. All right, 4 in the tens, meaning 4 is the first number, so the 10 spot. These are all ones, and now we've gotten up to the 10 spot. And like we said, 4 is going into the first spot. 40 is our first one. 42, 43, 44, 45, 49. All right, let's count up our numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's work on this last question. Find the probability of choosing numbers with the last digit 6. With the last digit 6. Now this does include 10 or 1s this time. It was not specific to a group of numbers. So this time we can use our entire set. Those are all of your numbers ending with a 6. Let's count up our desired numbers. All right, congratulations. We have just finished 58. I will see you on page 59.